Hi everyone, welcome back. We're going to be doing a walkthrough for Chapter 11. This is worksheet practice number 1, perimeter and area of two-dimensional figures. We've had a special request to look at, this is the worksheet, we've had a special request to look at in particular the very last page, and that is these ones where we're having to deal with trigonometry 16, 17, and 18. So I'm going to zoom in really close on 16 first. All right, so number 16, we have to think about first what information we have, then what information we're looking for, and then what skills and tools we can use to put all of that together. The first thing we notice here is that we're being given some sort of radius. And I know that it's a radius because it comes from the center of my polygon to the vertex of my polygon. That's the definition of our radius. What we're looking for is the perimeter, which means we need all of the side measurements, and the area, which means not only do we need its perimeter, but we're also going to need the apothem of this particular figure. The apothem is a special segment in a polygon, and it comes from the center of the polygon to one of the sides, and it does so at a 90-degree angle and right in the middle. It is the perpendicular bisector of a side going through the center of our polygon. Now these little properties, the fact that it hits at a 90-degree angle and it cuts a side in half, are going to be super important to us in calculating both the side and the apothem. All right, I'm just putting in some variables right now. So I've given x as a variable for that little half piece of the side, and I've used a as the variable for the apothem because it'll match the a that I have for the apothem in our formula for area of this polygon. But I'm missing one other piece of important information. I have the radius, it was given to me, that was 10. And I'm trying to find these other two side lengths, but what I need to do that is I need the measurement of this angle right here. In order to generate the measure of that angle, I need to first find the measure of one of these angles. Those are one of the interior angles of a regular polygon, which is what we have to assume that we're working with here. To find the measure of an interior angle of a regular polygon, we need to recall back to Chapter 6, Lesson 1, Polygon Angle Sums. I'll look to put a link on screen for you that takes you directly to that lecture. We need to figure out how many sides this particular polygon has. I've already started writing it for you. This has 5 sides. It's a pentagon. 1, 2, 3, 4, 5. And after looking back at the notes for Chapter 6, Lesson 1, Polygon Angle Sums, we see that in order to find one of the angles of an interior angle of a polygon, regular polygon, is this formula. N minus 2, whatever that is, times 180 divided by n. And in this case, the measure of n is always the number of sides in the polygon that we're looking at. So here is the substitution. Here is one part of the calculations. I've just subtracted 5 minus 2. And we're going to grab our favorite calculator app. Let me get the calculator app going. But I'm going to go to my calculator and I'm going to go 3 times 180, which my calculator app says is 540. And then I'm going to divide that by 2. So 540 divided by 5, When I divide 540 by 5, because 5 is the number of sides in my angle, I'm going to get 108. Fantastic. which means this angle measure right up here is 108 degrees, but that's not really what I'm after. I mean, I need it, but that's not what I want. What I wanted was this angle right in here. Notice the radius. The radius of a polygon bisects one of these vertex angles. That means it cuts it into two congruent pieces. So I have two congruent pieces that when you add together give you 108. Well, that's half of 108. So the measure of that angle, in this case, is 54 degrees. I took 108 and I divided it by 2. So now I have an angle measure and one side, and I can use that along with trigonometry to calculate the other two sides that I'm looking for. Let's remind ourselves of our trig. So recall back to our trigonometry. We have the sine, the cosine, and the tangent. Right, let's see what we have here. Here's our theta, the angle here in the corner, 54 degrees. And then we have information on the radius, which is directly across from the 90-degree angle. That means this is our hypotenuse. Since I have information about the hypotenuse, for this particular one, the tangent doesn't apply. It doesn't give me any helpful information whatsoever. So I'm stuck between the cosine and the sine. Well, if we look at our sides here, what we have measurements of, I've got this side right here opposite theta, which is this one. So sine will help me calculate the apothem. Notice how the outside right here of your polygon, this piece, is adjacent to your angle. Cosine is adjacent. So in this example, I can use cosine to help me find the side length of the polygon, and I can use sine to help me calculate the apothem. Go ahead and try that now. Pause the video, and when we come back, I'll walk you through it. All right, welcome back. You've already gone and given it a try. I'm going to go ahead and do that setup. We'll do the apothem setup first, and then we'll work on the side length. So the apothem gets calculated using sine of theta. Theta, in this case, was 54 degrees. So I'm going to substitute for what I have. The sine of 54 degrees equals the apothem, which is the thing I want to know, divided by the hypotenuse, which was given to me at the very beginning. It was the radius measure. Now I'm trying to solve for this a here, the measure of the apothem, and so I have to think to myself, what's happening between this measure of the apothem a and the measure of the radius 10? In this case, they're being divided. 10 is doing the division, so to get rid of that 10, I need to multiply everything in my equation by 10. When I do that, I end up on the left-hand side with 10 times the sine of 54. And on the right-hand side, the division by 10 and the multiplication by 10 are going to kind of undo each other, destroy each other. And on the right-hand side, I'm left with just that variable representing the measure of the apothem. And now I'm in a position trying to find where I put my thing here. Here we are. And now I'm in a position where my calculator app is not loading. There we go. I'm in a position where I can start calculating. Come on. There we go. I can start calculating this measurement right here. 10 times sine of 54. All right, so just trying to see what I've got going here. Sorry, give me a second. All right, so 10 times, now I need to find where the sign button is. The sign button is found under the trig menu, which is right here next to the number 7. Go ahead and scroll over till you're highlighting sine, S-I-N, and then your angle measure of 54. Hit enter, and when you're done, we have calculated, let me zoom in on it, there it is, that the value of the apothem is 8.0901. Now I'm going to go ahead and keep 4 decimal places for the moment. The answer says round to the nearest tenth, so at the very end you have to round it, but for now we can leave it at this. Okay, let's go ahead and set up and look at the cosine. I'm going to go ahead and close my calculator app for now so that we can see our cosine. Here it is. Remember that the adjacent one was x because the radius was the hypotenuse. So I'm going to go ahead and fill in what I know. The cosine of 54 equals the outside edge of the polygon divided by the radius of the polygon. Just like what we did in the previous example, because the variable that I'm looking for is being divided by 10, I'm going to multiply everything by 10. When I'm done multiplying everything by 10, I'm going to see that 10 times the cosine of 54 will give me the value of that piece of the side of the triangle. So again, going to pull my calculator back and let's calculate it. 10 times the cosine of 54 equals, zoom in on that answer, and I'm showing that that side measurement is 5.8779. Okay. I'm going to go ahead and go back to my figure and I'm going to label my information. .8779, and then the apothem was 8.0901. All right, I have just enough information here to begin my final calculations. I need the perimeter. Remember that the perimeter is given by adding up all of the side lengths, but I need the entire sides, not just pieces of them. And what x is representing is just this piece, 1/2 of the side. So please don't forget to take a moment and multiply that value by 2 times 2. So when I multiply that by 2, my side length becomes 11.76. I'm going to go ahead and start the rounding process because I'm tired of writing all those decimals. And then the perimeter is going to be that value times 5 because I have 5 sides. Let me zoom in on the answer. There they are. And so the perimeter is 58.78, but you have to round it. So it's actually 58.8. Don't forget that you are rounding to the nearest tenth. Once you have your perimeter, you're going to get your apothem and fill into the formula. So, let's use the right color here. 1/2 times the apothem, which I calculated at 8.09. Again, I started to do some rounding. times the perimeter, which I calculated at 58.78. You can use this one or the fully rounded version, whichever you prefer. And we're going to go into our calculators. So 1/2 times the apothem times the perimeter and this is that bottom value is our area, 237.77. Please make sure that you round it to the nearest tenth. You're going to look at that first 7, then at the one under it, and make your decision. All right, that one is fully done for you. Let's start the setup on number 17. Number 17, we're looking at the same sort of thing. We have a regular polygon, and we're trying to find the area and the perimeter. We have to first decide what information is that we're being given. Looks like we're being given this information. This is a side length. So to find the perimeter, we just take the side length and multiply it by the number of sides that we have. So let's figure out how many sides this shape has. 1, 2, 3, 4, 5, 6, 7, 8. This is an octagon, 8 sides. So your perimeter is 8 times the side length of 15. So go ahead and take a moment, calculate that out. I won't give you the full answer for it, but you have your formula. The next thing that we need to work on is finding the area of this polygon. Again, there is the formula for the area of a regular polygon, 1/2 times the apothem times the perimeter. By this time, you should have the perimeter already written down, and so all you need to do is find that apothem. Let's draw in the apothem. Remember that the apothem is a segment that goes through the center and is the perpendicular bisector of a side. So there is an apothem. I'm going to label it A. And I'm going to go ahead and show where my radius would be. So here's a radius. It creates our right triangle. Like the example above, this right triangle has an angle measure right here that becomes super important to us. In order to calculate that angle, we have to find the measure of this interior angle. We're going to use this formula in order to calculate the measure of that angle. And then this one, the angle that I'm actually interested in, is whatever we got up here divided by 2. Once you have the measure of that angle, then you can use trigonometry to help you find the measure of the apothem. First thing we need to do is find the measure of this little bitty bit of the side. That is 1/2 of the full side of the polygon. 15 divided by 2 is 7.5. Now let's look at our trig functions once again and decide which one can be of use. Here are the 3 trig functions: sine, cosine, and tangent. Looking at this particular right triangle, I noticed something. I noticed that information about the hypotenuse is missing. Because I have no information about the hypotenuse of this right triangle, I am not allowed to use sine, which requires use of the hypotenuse, nor am I allowed to use cosine, which also requires use of the hypotenuse. I must use tangent. Let me show you the substitutions that you'll do for tangent. So we keep the triangle in frame here for you. So tangent of theta. Theta is going to be this value right there. I know that I have here written theta divided by 2, and it's because I'm borrowing this symbol theta from over here. So it's the measure of that angle, the one you calculated right here. That equals whatever we're looking for from the apothem divided by the side of the triangle we already know. Using the same technique as you saw up in the previous example, solving with sine and cosine, you will do the same thing to solve this for the apothem. Yes, they're on my desk if you'll bring them up. Thank you. Okay. You'll get a value for the apothem, whatever number that is, and that's what you'll use right here to generate the area of your polygon. Right, let's look at the final example, question number 18. Number 18, very similar. Once again, we have a regular polygon. Once again, you're being asked to calculate perimeter and area. So once again, we're going to be using this formula, 1/2 times the apothem times the perimeter. But looking at this particular example, which side do we already have information about? Or rather, what segment do you already have information about? Thank you. The segment that we already have information about is this segment right here. See you tomorrow. Thank you. This segment right here, sorry, students are leaving for the day. This segment right here goes from the center and hits the side. We have to assume that it does that at a right angle and that it hits directly in the middle of the segment, which means this is an apothem. So we have this value right here. In my formula, I can already begin substitutions. Now I just need to figure out what the measure of this side length is right in here so that I can then multiply it by 2 and calculate the perimeter. Like I did in the previous example, number 17, I'm going to add in the segment that creates the radius so that I can see where my angle is. This is the angle that'll help me with the most information. And just like in the example above, I will use the formula for a single interior angle to calculate the measure of this big angle, which I will then divide by 2 to give me this one. Once again, I'm setting up my trig functions, but I'm looking at having, remember that this 6 is to this segment down here. So when I'm setting up my trig function, let me just write my trig functions again really quick. So you have your menu. There it is. I am looking at which sides I have information on based upon my angle. Here is the angle that you will have already calculated the measure of. I have information on the side opposite that particular angle. This means that the cosine function is out because it doesn't deal with the opposite side. And I have information on the side that is next to the angle. Notice how I picked this one as next to and not this one, even though yes, I know that this side is next to the angle. But this side is reserved as the hypotenuse because it's directly across the 90-degree angle. So this is the hypotenuse, which I don't have information on, which means I can't use sine. So this one requires use of the tangent function. Make sure that you take a moment to substitute what you have information for. I'm going to use the same symbol, that black dot, to represent the measurement of this angle right here. I'm going to get information on the side opposite that angle, which is the apothem, measurement of 6, divided by the side adjacent to the angle, which is the piece of the side that we are looking for. Now, to solve this one, the technique is very similar to what we saw above. However, the thing that we're going to multiply the equation by is not a number, but rather this variable. We are allowed to multiply by variables. I know it looks trippy and weird, but we can do it, which turns the next line into something like this. Remember that black dot is representing the measurement of the angle, which you would have already calculated. I'm not going to do that for you on this one. We did it already. Remember that this value right here, the tangent of whatever measure that angle is just a number. It's like 2 or 3. You can find it in your calculator. Which means in order to undo this multiplication between the x and the tangent of whatever the angle is here, I can divide by that value. And so the measurement of x, which is the side length that we're looking for, will be given by the measure of the apothem divided by the tangent of that angle that we were looking at earlier. Reminding you, the angle in question is this one right here. That will generate the side length, which then, like in the very first example, number 16, you can multiply by 2 to give you one side. That will help you generate your perimeter, which in turn will help you finish your area. All right, that is the walkthrough for all of the polygons. I hope that that helped you out, and we'll see you in class. Thank you.